Hi, I'm Austin Griffith. I want to show you scaffold-eth. It's a good way to build applications on top of Ethereum. It starts with an example smart contract, and when you make a change, you add something in, the smart contract auto-adapts. If I remove this owner and I hit save and I deploy, we're going to see that owner disappear from the front end. So it allows you to edit your smart contract, try something new, and then deploy it to your local chain, and then you have your local app auto adapts to that, and we can grab some funds from the faucet and we can poke at this contract. But this is scaffold-eth. It allows you to work on a smart contract, tinker with Solidity, learn Solidity, and also build this app in the front end. It's automatically adapting to what you change in your smart contract, and it helps you create a front end, so whenever you add a new function, there's a new button that represents that, and you can play with your Solidity and learn kind of as you go. So that's scaffold-eth, and I'm going to spend most of my time talking about that, but I want to zoom out a little bit. If you're getting into Ethereum, the best place to start is to go to ethereum.org. Etherscan is cool too. But if you go to ethereum.org, this is a great place to learn about Ethereum. You'll want to get a wallet. You'll want to learn where to get ETH. You'll probably get a MetaMask, and then with that MetaMask, you can interact with apps. Then learn what ETH is. Learn why we're decentralizing. Learn why decentralized finance is important, and DAOs and decentralized governance, and NFTs, and the history of Ethereum, and ETH 2.0, and here's my staking node right here, my ETH 2 node. You learn about all that stuff and where we're going, and then it's time to develop. It's time to build. So I would start with learn by coding. You can pick up Remix and you can write a smart contract right in the browser, or you can use ETH Build. And ETH Build is one that I've put together to help you with the fundamentals. Just understanding what's a hash function, what's a key pair, what can you use a key pair for, how does it sign and recover messages, and then on to through encryption and distributed ledger and Byzantine general, and then eventually blockchain and smart contracts. You'll get to all that, but what you can do is you can get in here and you can tinker and you can kind of figure out how things work. Here we have a key pair, and I'm clicking this button and I'm generating a brand new private key which derives a public address, and we can use that private key to sign, you know, some message. Whoops, deleted it. Hello world. So we can use that private key to sign a message, and then that message and that signature can go across the network. And then if you hook up that message and that signature to a recover box, you can recover basically the address that signed the message. Notice how these two addresses are the same, and this goes across the network. So that's a superpower of these key pairs, and this is what allows all this to work, and it's Ecdsa is what it's called. Ecdsa. You can learn some more about the curve and elliptic curve cryptography. That's way over my head. I'm just a builder, but ETH Build will help you get started and poke around and learn some of the fundamentals. Then you can bring in blockchain and you can do a lot more. Let's see what the current block number is on Ethereum. Whoops, it's not Tegway, it's right there. There's the current block of Ethereum. So that's what you can use ETH Build for, and eventually you can, you know, talk to smart contracts. You bring in the address and ABI, and then you get an interface. And there's a lot of things to learn from down here in the drawer. Let's just get into like a really big one. Let's look at the Byzantine general. Whoops, not that one. There's videos that go along with all of these, but if I load this up, here's all of these soldiers, and they're showing how proof of work works. We can see this soldier in here jamming away at a hash, and then if we look out here, all of these soldiers are doing that, trying to find a hash with leading zeros that hashes General Bob's message, so he can send it out to say he wants to attack Monday at dawn. So that's kind of an exploration of proof of work. ETH Build is a good way for you to kind of learn about key pairs, learn about just some of the fundamentals. Once you've got the fundamentals down, you're ready to set up your local environment. And there's a lot of great tools to set up your local environment, but the one I'll be talking about today is scaffold-eth. It's ethers.js, which is probably here too. It's ethers.js plus Hardhat plus React. So it's kind of everything working together at once. When it's really complicated to build a stack in Web3 and build on top of Ethereum. There's a lot of tools and there's a lot of things that can go wrong. With scaffold-eth, we start with something that works. We have a back end, which is basically our hard hat blockchain, and we have a front end, which is our React, and we're using hard hat to compile and deploy, and then we use our front end to poke at that contract and interface with it. So this gives you a full dApp template out of the box, and it helps you learn Solidity, and then it helps you kind of build a bunch of different things to kind of learn the tour of duty, learn all about all the different things you can build on Ethereum and what works and what doesn't, and some of the gotchas. Okay, let's go ahead and dive into scaffold-eth some more, and let's write just a little code to kind of get you familiar with how to use the tool. So let's say we're going through this documentation and we look at primitives and data types, and oh, whoops, that's not what I meant to do. I wanted to click that. We can see if you're a good programmer, if you're a good Web 2 programmer, you should be able to get right in and understand this. So we have unsigned integers that with 8 bits, or we have an unsigned integer with 256 bits. We have addresses, we have bools. Let's just grab one of those here. Let's just grab this address and bring it in. We kind of had one here earlier, and let's go ahead and copy my address from the front end. Now if I save that and I deploy it, we should see that a new address is added over here, over on the right here. There we go. So now that's the address. And let's, instead of calling it address, let's call it owner. And then let's write our first rule. So Solidity requires, it uses this phrase require, and it's like assert. It's checking a condition. So if you require that the message.sender equals owner, and what that's saying is whoever gets in here, the message.sender is the person calling this function. So whoever gets in here, and or the last person, it can be a chain where you talk to a smart contract and a smart contract talks to it. That's too complicated. It's the person who's calling the function. And so what we're checking right here is we want only the owner to be able to get in here and set the purpose. And if you're not the owner, we'll say not the owner. Okay, and we'll add our semicolon there, and we'll yarn deploy. I can make this a little bit bigger too, make that look a little nicer. There we go. So we deployed our new contract. We're building Unstoppable. Let's say apps again. I like that better. And let's save that and deploy it just so it looks nice. Oops. There we go. Okay, what we have is an owner that can update this storage location. So we have this string purpose, and we have this function that lets us update that purpose. And then we've added this new owner, and we said only the owner can set the purpose. So over here I should be able to say hello, and if I hit send, sure enough the purpose updates. Now what we need to do is test the other case, right? Test the bad guy, right? We want to see someone else come in. So what I'll do is I'll create a new incognito window, and I'll go to localhost, and you'll notice that I have a different address in the top right. See how this one is kind of green and pink, and this one is kind of like a purple and green? They're a little different, right? We'll call this pink guy and this purple guy. So we'll go to the pink one, and he goes and he grabs some money from the faucet, and then he trying this, and it should fail, right? It should say not the owner. There we go. So we've tested this line of code. We've tried it from someone else, and they're not able to set the purpose. And we've tried it from our account, and he is able to set the purpose. So this line is working pretty well, and it's keeping out other people, and that's pretty good. What we've built here is sort of like an attestation smart contract, where one person, whoever controls the private key that goes to this address, they're allowed to get in here and update this purpose. Well, that's not that interesting. Let's think what we can do to make this more multiplayer. Let's think of this more like a vending machine that anyone can get to. So instead of having it set up so one owner can get in there, let's set it up so it's payable. Okay, and then what we'll do is we'll say message.value needs to be greater than or equal to 0.001 ether. Okay, and we'll say not enough. Okay, so we've changed the rules around. This address isn't important anymore. We don't need an owner anymore. It's not owned by anyone. In fact, when we deploy this smart contract, if we do it correctly, not even we can stop it. No one's going to be able to stop this vending machine. It's an unstoppable vending machine that lets anybody get in here and pay 0.001 ether if they want to update this string. That's a pretty cool little build. Okay, let's see. Let's go ahead and deploy this and see if I've done anything wrong here. See if it's happy. There we go, compile, deploy, and now our front end updates, and there's a new field here to put in the transaction value. So I'll say hello world, and I'll do 0.001 ether, and we take that ether to weigh by multiplying by 10 we multiply by 10 to the 18 because these Ethereum nodes, they run an EVM, and the EVM needs to be simple, so it doesn't want to do floating point math. So instead of having decimals built into the EVM, we basically multiply everything by 10 to the 18 to kind of create a fake decimal system, sort of, right? So 1 ETH equals 10 to the 18 way, right? So when I want to go 0.001 ETH, I need to do this 10 to the 18 to take it to, and so this value right here is the same as this value right here. See that? That's the same, but it's easier for humans to read a decimal, but the machines need it in whole numbers. There we go. We pay, we call this function, which crafts a transaction, and it pays to update the purpose. So we pay money to update the purpose. We pay this much ETH. And you can see now the contract has money in it. So the vending machine is starting to collect value as people set the purpose. Okay, well, wait a minute. We don't have a way to withdraw that money, right? And anyways, I want to show off the superpower of Ethereum is that you can innovate on top of this blockchain. So if you imagine, let's back up a little bit, and when someone says, what does a blockchain look like, right? What does a blockchain look like? Well, most people would say it probably looks like a set of blocks in a row, right? They probably would say that a blockchain looks like this, right? And it's like these chain of blocks, and it's pointing to the previous one. Well, that's true, right? But actually, if you want to think about what it physically looks like, it's all of these nodes, right? It's all these nodes on the network. So a blockchain looks more like this than anything, where it's a peer-to-peer network, and all these machines are communicating peer-to-peer, and they're coming to a consensus about what let's think of a distributed ledger first. So Bitcoin comes to the consensus of what a distributed ledger values are. Alice sends 1 to Bob, Bob sends 2 to Charlie. Everyone on the ledger is keeping track of it, and everyone's agreeing. With Ethereum, that ledger, it's not just a ledger, right, where we're keeping track of to and from. It's actually an execution environment. So it's a small little computer, and everyone runs that small little computer. That's not a very good drawing, but imagine this is a little computer, and everyone is running their own little computer. And when you deploy this smart contract, every node on the network gets a copy of your smart contract. And whenever you want to call a function that updates it, when we call this update string, every node on the network has to update their string to the new value. And so this distributed ledger that we're keeping track of is actually an execution environment, and it's executing transactions, and everyone is keeping track of this chain of blocks that kind of secures it with proof of work. So it's very, if we want to think about Ethereum from a Web 2 perspective, we can think of it like a database, where when you have a database and you have lots of people hitting it, you need to scale up and you need to add more redundancy. Well, with Ethereum, every single node is the redundancy. So part of the network can fall apart, and you can still ask any of these other nodes that are still here what the value is. So it has censorship resistance. Then there's this trustlessness, where the only thing you have to trust is the code. We know that this is going to do exactly what we program it to do. When I said that when we deploy this, not even we can stop it, that's exactly how you want it to work. You want to be able to deploy a smart contract that does exactly what it's supposed to do. Okay, so zooming back in on scaffold-eth and building on Ethereum, we've built ourselves a little vending machine here, and it has some money in it. We need to probably withdraw those funds. We need to think of it like adversarially, though. Can anyone attack this? Is there anything wrong with this? Is there anything we could maybe add to this to show off how we can program that top layer. So thinking of that blockchain, right? That big network of all those machines, they take care of the blockchain-y stuff for us. It's our job to just write our little rules in here, and we can innovate quickly by writing little rules in here. So let's see, what could we innovate on? Let's do something else. Let's do a uint 256 public price. So I'm going to keep track of a great big number, and I'm going to set it, and I'm going to call it the price, and I'm going to set it equal to 0.001 ether, and then I'm going to replace this here. Basically just set a variable to what we want the price to be, and if I deploy that, it should work fine. We shouldn't get any problems. I should be able to go back over here, hello world, and I should be able to send that same exact transaction, send some money in, and set the price. So that's cool. Let's think a little bit more about economics. Let's think about how we want to create some mechanism design here. And let's think, what if we do something like this? Okay, so the innovation we're going to add here is we're going to say the price equals price times 1001 divided by 1000. What that's going to do is slowly increase the price, okay? So then let's go make sure we get the order of operations correct. There we go. So we make sure we take, remember, no decimals. These are all whole numbers. So we want to do this first before we do that. Okay, I think this is going to work. Let's go ahead and yarn deploy this and see how it looks. What we're doing is we're adding innovative mechanics on top of a smart contract by just adding 1 or 2 lines of code, and all of a sudden that whole system is going to work a little differently. Okay, so the first transaction I'm going to send, but now look at this, the price has gone up. Okay, so the next, if I say hello world 2 and I send this, oh, look at that. The price is going up a little bit each time I create a new one. And you can see there's more and more money going into the smart contract. So just quickly, we just came up with, let's make a price function, and then let's make the price go up on a curve. We just threw it into the contract. We tested it a little bit in scaffold-eth, and basically we're ready. We've got this app ready to go. We would eventually probably build out some example UI, and we'd make it a little cleaner. We wouldn't have them do this, right? We would have that built into the UI, so it does that behind the scenes. But this is built for developers. This is ready to go. This is built for developers to work on their smart contract and learn Solidity. You'll want to carve this out and actually build your own front end as you go, but a lot of it's going to be right here, and the example UI gets you really close to having it and listening to events and lots of other stuff. Okay, so you've got it. Let's say you've got scaffold-eth figured out, you've built something, you're ready to deploy it. You'll go to the hard hat configuration and you'll choose your network. You want to go to mainnet? Let's send this thing to mainnet. You want to go to a testnet? Let's send this thing to a testnet. So you can pick your public network. You can yarn generate to create a new account. Then you fund that account, and then you yarn deploy. And instead of deploying to localhost, it's going to deploy to whatever network you want to go to. And then you make one other change. You go to your front end and you go to your app.jsx, and you'll update this network right here to mainnet or whatever you want, and it's going to work on that network. And then you can yarn build and yarn S3 or yarn surge, or send that, basically build your static website that's pointed to your contract that's already out on a public network. You'll put your app out on a public network too. So then you can basically give someone a URL and they can interact with your smart contract app. Okay, cool. So that's how you would deploy an app. Once you've got scaffold-eth down and you've experimented and you've learned all of these different things to learn, right? You need to learn primitives and data types. You need to learn mappings. And what you do by that is you'll click on a mapping, you'll go into here, you'll find a mapping, and you'll bring it into your smart contract, and you'll say, well, what does this look like? What does this mapping do? It's a mapping from an address to a uint. Okay, so what it is basically, think of it like balance, right? It can give you the balance of any given person. So if we put our owner in there, and we set the balance of the owner equal to 100, and we deploy this, now we've just created a totally different thing. This is actually very similar to a token, like an ERC20 token. We've set it up so we keep track of balances, right? Okay, so what does a token need next? Well, it probably needs some function called transfer, right? And that transfer function will take some address 2, right, who we're sending it to, and some uint 256 amount, right? We'll make that public. And then what are our rules? What rules should we set, right? We need to make a rule, right? Let's require that the balance of the message.sender is greater than or equal to the amount. So basically they're wanting to send some amount, and we need to make sure they have that amount, and we'll just say not enough if not, right? Okay, and then once we know that they have that amount, what do? Well, we'll take their balance and we'll say that minus equals the amount, and then we'll take the balance of the to address and we'll say that plus equals the amount. And you just built yourself a token, right? Something that took a crazy amount of work 5 or 10 years ago, building a decentralized currency, you can build in a few lines of Ethereum. Let me hit save and let me deploy this. Let's see if it worked. And this is 100 Wei, by the way. Like if I wanted to be very specific, that's 100 Wei, not 100 Ether. So just watch out for that. But we're just dealing with Wei right now, and that's fine. I'm just showing how we can see a balance of a person. We could bring up an incognito person, and we'll send them some tokens. Okay, so we'll copy this address and we'll find our transfer function. We'll paste it in, and notice how it has a nice little blocky preview there. That's what scaffold-eth does. It has a lot of components and hooks that you'll use. And let's just go ahead and send them 50. And there we go, we sent 50. So now if I check this guy's balance, he has 50. And if we go check this guy's balance, he's got 52, so it worked. And that's a mapping. That's how you learn what a mapping is. You kind of look at these examples, you paste them into scaffold-eth, and you tinker around with how these work. So that's a mapping. The next thing you'll want to learn are structs, right? And that's a struct of primitive data types. Maybe make a to-do list, add things and remove things from the to-do list. Then you'll learn modifiers. It's a way to write those rules in a way where you can have just one rule and then you can apply it to other functions and not have to rewrite those require statements. Events are really important because they give you information to your front end. The smart contracts can emit events, and you can read events from the blockchain. So events are stored on the blockchain, but they're not stored in a way where other contracts can talk to them. So the gotcha with events is they're only for your front end, they're only for humans to read, they're not for other smart contracts to react to within their logic. So the gotcha there is events are great for getting information out, but they're not good for using smart contracts to talk to them. Inheritance is really important. So once you see that ownership pattern that we set up earlier where only the owner could do something, what you want to do, instead of writing it yourself, you'll probably want to go to OpenZeppelin and just bring in their ownable pattern. And you say, this is ownable. And now we can go down here and we can say only owner, right? And now only the owner can get in. And, oh, I didn't spell it right. Let's spell it right. Only the owner can get in there and call that function. And instead of having to keep track of an owner and set up the modifier and set up all that work, set up the require function, we can just bring in OpenZeppelin's code. And so you can bring in a lot of other tokens and a lot of other things from OpenZeppelin. So check that out. Once you've got inheritance, check out the payable and the fallback function, and then you're ready to start in on the challenges. There's a whole Ethereum speed run. This is just learning the language. You've just learned the language. You've just learned the global units. You've learned kind of what message.sender and message.value and block.timestamp is. You kind of get it. You're a programmer and you understand enough solidity to be dangerous. What should we build? That's what this is for. So here is the ETH dev speedrun. So I found kind of through teaching people how to build on Ethereum, there's a bunch of concepts that you need to go through to really understand why Ethereum works the way it does, what works on it, what doesn't. And it all starts with tinkering with Solidity. We've already talked about that, going through those original concepts. And then check out the simple NFT example. Basically, it'll just walk you through minting your own NFT. And if you want to get in there and make some small changes to that contract, here's your NFT contract right here. Very simple. It brings a lot of stuff from OpenZeppelin. Then extend that branch to a buyer mint. Set it up so instead of the artist paying for the NFTs, set it up so only the buyer has to pay for the gas, or the buyer pays for the gas for the NFT, not the artist. And it's just a small change that you make, but then there's a gallery where people can get in and mint those NFTs. And then from there, you're off to the races. There's a decentralized staking challenge. You'll learn payable functions. You'll learn block time. So is it after this certain time? Then let's execute something else. You'll move on to the token vendor and challenge 2, where you'll learn how to deploy a token. You'll learn how to deploy a token vendor. You'll buy tokens from your vendor, and then the hard part, you'll have to sell your tokens back to the vendor. And this is complicated because the approve pattern in ERC20. It's actually 2 transactions. One to the token contract to approve, and then another transaction to the vendor to have it go grab your tokens and then give you back ETH or whatever. Play with commit reveal. Randomness is really hard on a public deterministic blockchain. Learn why that is. Learn what commit reveal is. Learn how you can use an oracle to provide randomness, and then learn more about oracles. Learn how you can bring in feeds from an API into your blockchain and the pros and cons of doing something like that. Learn how to build a decentralized exchange. So instead of an order book that could get hacked or fall over, you can actually exchange tokens for ETH in a smart contract, and the trick there is you hold reserves of each and you trade between the two. Get into that, learn how to build your own DEX. Then there's a lot of DeFi stuff, learning bonding curves for ERC20s, learning how to build your own swap in the front end, learning how to build your own lending functions, and then ape into learn how to leverage up with a smart contract. And then signed messages are big. Going back to that key pair where we could sign and recover messages, you can do that off-chain in something like a state channel, but you can also do that on-chain. Like a smart contract wallet can require signatures from a handful of different signers, and you can get all those signatures together off-chain and make one transaction on-chain. There's the Ecdsa library, there's meta transactions, and then the final boss to beat on the Ethereum speedrun is to build your own signature-based multisig. And I have an example here, but it's best to build it yourself. So check out Solidity by example, and there's a lot of great examples here, including the hacks. Learn how reentrancy works. Learn how some of these hacks work. Look at audits and look at how auditors have given feedback on other smart contracts. Get in here with scaffold-eth and build a bunch of things. Follow this speed run. Get into the chat. I'm at Austin Griffith on Twitter. Let's see, right here. I'm at Austin Griffith on Twitter. Reach out. My DMs are open. Again, check out scaffold-eth. This is the place to start right here. If you want to get the fundamentals, go to eth.build. But once you have the fundamentals, jump into scaffold-eth and check it out. Good luck. Build something awesome on Ethereum. Have a good day. Bye, bye, bye.